Llama 3 was released last week, so there are so many people excited for it. The model is pretty much breaking every benchmark out there. It is also said that the 8 billion model is outperforming the 70 billion parameter model of the previous generations of Llama 2. So that's crazy. It has been trained with 15 trillion tokens. Let me just go to the Meta website and show you what's the new features. And then in today's video, I wanted to show you how to do a document Q&A, where you are uploading a PDF and then you are running the Llama 3 model, 8 billion instruct model, locally in your own PC, and how we are getting the results out without any hallucinations, without any wrong answers. We are trying to use advanced RAG, Retrieval Augmented Generation, to solve this problem. So let's get into the video. So this is the official website of Meta, where they have launched Llama 3, and if we go down, we can see that there should be the performance metrics. Yeah, so here are the performance metrics where Llama 3 instruct model performance is benchmarked. It is pretty much outperforming Google's Llama and Mistral 7 billion instruct, and the 70 billion parameter model is better than Google Gemini Pro 1.5. Wow, in most of the use cases, and it's pretty close to the highest benchmark anyways, and it's better than Claude 3 as well. That's awesome. So today we'll be using the 8 billion parameter model, and let's go. So I went to YouTube and started searching Llama 3 document Q&A. There was no official or examples from any other YouTubers, so I thought I'll do an example here. So for this video, we'll be using Ollama. Ollama is like a tool that helps you to run the large language models that are open source, like Llama, Mistral, Gemma, and other models on your local PC in a quickest possible way. So make sure you download it for your respective operating systems. Mine is Windows, so I downloaded it and installed it, and you can see here it's running in the background. That's very important, otherwise it won't work. And let me go to the code now. Yeah, so this is the Jupyter notebook that I have made, and thanks to the LangChain team for their awesome contribution, where they are trying to help us all out by showing all the advanced RAG techniques, and they have also made one for Llama 3 as well. So that is the reference notebook that I took, and then here they are doing basically from the URL, but in our case we will do it from PDF. Okay, so thanks to I'll make sure that I'll put the link to the RAG repository. So let's get into the code. So here basically I'm installing all the libraries. One good rule of thumb is, when everything works, in my case at the moment everything works and all the libraries are fine, you please start version locking. What do I mean by that is trying to put the versions and remember the versions, and make sure you type the versions as well, so that it doesn't break in the future. Okay, for example, tick token is 0.6.00, so I'll put 0.6.0, so that I'm locking it forever, so that it doesn't break in the future. So yeah, that's a good habit, because I've been working with this large language model for the last one and a half years. It's really annoying when suddenly everything starts to break. So yeah, let me run the code. All the libraries are pretty much installed in my kernel, so it just took 5 seconds. In your case it might be longer. So one more interesting thing is, always start with a new environment. Go to Anaconda I'm using Anaconda inside Visual Code Studio. So I created a new environment with Python 11, and then I install these libraries. So it's a fresh environment, so everything is new. So that's always better. Do not work in your existing environment, because there is a lot of version mismatch that happens. Yeah. So the thing is, the LangChain team has introduced three papers that they have used in their architecture, so that the model doesn't give us wrong answers, or the retriever takes the relevant documents for the user's question, and also does not hallucinate, and also gives the answer that is relevant to the user's question. So this is the bigger picture of the architecture. Let me just run through it. So this is where the user questions go. There is a routing method or a function where what we are doing is, we are taking the user's questions and trying to search through the vector store that we are going to create for the PDF documents, and then see whether the user's question can be answered through the vector store. If not, we can go through the web search. So that's the first step. The next step is where this paper comes along, like routing, where the retriever tries to get the documents in very different methods and different approaches, and then there is a grader function. What the grader does is, it tries to match the user's question with the different chunks of documents that you have chosen, the retriever has given, and see if there is a match between them, is there is a relevancy or not. If they are not relevant, then go to the web search and try to find more content that are relevant to the user's question. If they are relevant, then go to the next step of generating an answer. Okay, so now this is the most interesting part, where hallucinations are handled. You can see here, and of course this is the fallback, where if it is not happening, go to web search. If it is making sense, the documents that are retrieved are making sense, go to the next step of generating an answer. How to fix hallucination, how to not let the model make up its own answers. Okay, so for that, what they are doing is, whenever the LLM is generating an answer for the user's question with the retrieved document or through the web search, however it is, this answer is compared with the retrieved document or the web search content. Okay, let's assume for simplicity, in this case, the user asks the question and it is there in the vector store itself. So, and we are basically getting the answers from here. So the hallucination method or function now compares the content in the document and then the model's answer. Are they both correlating or not? That's very important. That's one way to prevent hallucinations. And then if it is not hallucinating, go to the next step. So what is the next step? Is the user's question being answered here? Even if it is not hallucinating, sometimes it can give answers that seems relevant, but it is completely missing out on what the user asked here. So that's where the answer question method, what it does is, it compares the LLM's answer with the user's question one more time. So same like here, is it relevant or not? Here it compares the answer with respect to the user's questions, and if not, it falls back to the web search. In future, you guys can change it a bit. If you don't want web search, you can just put here like you just want to have some private documents that you wanted to ask without talking to the internet. You can just, instead of going to web search, you can just have a print statement saying that the vector store or the documents that we provided does not contain the answers for the user's question. So that's one way to solve it, right? Yeah, you can completely remove web search everywhere. Here also, if there is no relevant document, that means here itself we can say with the print statement that the user's PDFs are not having the answers for the user's own question. Yeah, so this is the bigger picture. So now let's go and run the code. Okay, so here I'm using GPT for all embeddings, and this is the library for it. It's all up there. So it's all up there, and as I said, we are running Ollama to pull the Llama 3 model and make sure it is running in the background. Okay, and yeah, here I'm mentioning the my language model. Here it's Llama 3. And yeah, let's go to the first chunk of code where I'm loading the PDF data. So here are some three random PDF. In this case, all three are the same for simplicity. Let me show you the PDF that I have. And this is the PDF I have. So it's basically, I'm a medical student. I study veterinary medicine. So I'm basically studying pharmacology. So I have some list of drugs that affect the nervous system of the animals. So you can see opioids, alpha 2 antagonists, agonists, anesthetics, analgesics, all those things. Okay, so it's all some medical drugs, and they're examples of those class of drugs. So yeah, I'm uploading them, and I'm splitting the document into chunks if needed. If not, you can just remove that piece of code, and then you're putting it into a list, and then you're passing it to the ChromaDB for creating a vector store with GPT for all embeddings. Okay, so that's very important. And then you're calling the retriever finally. Let me run this code. So it took 1 second. Nice. Yeah, so now we are going to the retrieval grader. So where is that piece of code? It's here. We are grading whenever the user asks the question, the retriever gets a bunch of articles or documents inside the vector store, from the vector store, and we are grading it. So that's what is happening here. So yeah, you can clearly see here you are a grader, and then you just grade the retrievals, whatever the documents it is being given, and it don't need to be stringent. And the goal is to filter out the erroneous retrievals. That's very important, because sometimes we force the large language model to take context or the retrieval documents that are completely not relevant to the user's question, and force the model to answer it from that paragraph. That's one of the reasons large language models output performance generally is not good, and give us a binary answer, yes or no. And yeah, and then please provide it in the form of a JSON. Okay, JSON as also in the form of a dictionary, with score as the key, and the value is binary yes or no, right? Yeah, and all the retrieved documents goes here, and the user's question goes here, and it tries to grade it. And yeah, this is the retrieval gradle method itself, and this is taking in the prompt. And then it's very important that to use a string output parser instead of a JSON parser. In the LangChain examples provided, it's basically JSON. So there are a lot of things you have to change, so be aware of it. Yeah, for example, here they are using a lot of JSON parsers, so we won't be using any of those when working with PDF. If it is a web link, it's fine. URL links, it's fine. In this case, I'm just asking drug names. So I'm checking whether the user's question, this is my question, is it relevant to the vector store? Yeah, of course it is relevant, right? We just saw the list of drugs that I gave it as an input, and it is saying yes. You can see here the score is yes. Whenever it says yes, that means they are both correlating. So we have successfully passed this test, and now we'll go to the next phase. Yeah, now generation part. So generation, where the model is generating an answer. And did I run this? I'm not sure. Yeah, awesome. So it is run, and then I'm creating a LLM response, as I said. Here once again you are seeing this is where the prompt where you're instructing to answer the user's question from the retrieved context. Okay, this is very important. You can tweak all the stuff here is to adapt the model's response. Okay, this is very important chunk where you have to do some tweaking. And yeah, and list of drugs, and then I just ask the question, just the list of drugs. Instead of asking a question, I'm just giving a statement here. So you can see like it is giving me some examples. Inhalant, okay, yeah, this is correct. Local anesthetic is protein lidocaine, yeah, this is correct. And CNS stimulants, yeah, caffeine, yeah. And note that this is not an exhaustive list, and context only provides a selection of drugs. Okay, because I have given here use 3 sentence maximum, not a lot. Be concise with the answer, so it is not giving me the entire list of drugs, right? So yeah, awesome. Let me run this code again. Yeah, sometimes it gives the entire list, sometimes it does not, so that's also something to be aware of. And the next one is hallucination grader. So where are we? Here. So this is basically a grader that asks whether the answer is grounded in or supported in the set of facts. So here also give answer yes or no. What the term grounded in or supported means is basically the answer is within the context of the document. Yeah. And provide a JSON reply, simple binary reply, yes or no. And I'm giving the document and then a model's answer, and then a string output parser, very important. And then let me run this thing. This is very important to include the code json.loads. If you are not gonna include it, it's basically giving you a string output, which is here in this case this is supposed to be a dictionary for the entire LangGraph to work. If it is going to be a string, it won't work, so make sure you include this piece of code to convert this back to a dictionary from a string output. The reason why it gives string is because of this. Okay, in the LangChains example they are using JSON, so it automatically comes as a JSON, so it's not a problem. In our case it could be a problem. Yeah. And finally, does it make sense to the question, right? Does the answer make sense, right? Let me expand it. Yeah. Yeah, this is a model coming up with. Yeah, very spoiled with the autocorrect, so almost everything the spellings are so wrong. Yeah, let me run this as well. Yeah, it's correct. And the final piece of the puzzle is done. So now the router part. So this is where we are deciding whether to go to a vector store or the web search. Okay, so see, it just tells me the same thing. It's so straightforward, guys. Just read the code and not be intimidated by it. And yeah, and give me the output as vector store or data or web search. See, binary choice, web search or vector store, and return a JSON thing with no explanation. Okay, preamble or explanation. So that's very important. Otherwise, the model starts explaining why it chose the answers that it chose that we don't want. And yeah. Awesome. So if we are adding the web search functionality, so we have to add a search engine, right? So I'm using Tavily search. I created a free account. They give you 1,000 queries for as a free user, as a researcher, free plan. So you have to put your API keys here and then run this code. You can choose how many articles you want, 3 articles or 5 articles or however many you want. And nice. Now we entered the web search And now let's go and talk about the LangGraph, how the bigger picture looks with all the individual components mentioned as a function here. So we create a class called graph state. Here it includes the state of every single variable that we are interested in, the question, which is a string, generation, the model's answer, the web search, whatever the content it brings from the web, and the document list, basically from where it's getting the answers from the vector store. So yeah, now you see the retrieve method is there. It will basically call retriever.invoke, basically our our retriever here. So this is what it's gonna retrieve the information from. And generate method was there. Rack chain, this is also there. Up, let me show you. Generate, yeah, rack chain, you can see, right? So yeah, this is what it is taking the answers from. And similarly it just goes on and on. Now grading documents, that's also there as a method, and here you can see whether the document is relevant to the question or not. Here web search is yes or no, and then for every single document it starts comparing. Does it make sense? Is the document relevant to the user's question? Yes or not? If not, go to web search. Web search is yes, that flag, the state of web search is set, right? Yeah, see? And route question. Yeah, just moving the questions to the web search part. And finally, generation thing, decide to generate. This decide to generate basically tells whether you wanted to take it from the vector store or web search. So that's what it does. See, if the web search state is set to yes, it will go to the web search. If not, it will generate. So we play with all these states, basically web search, generate, all those things we play with. By changing the state, you are changing the code, basically which chunk should be accessed. And then this is the piece where you check for hallucinations. Like, a very interesting piece according to me, because I have seen large language models do a lot of mistakes. And yeah, the decision is grounded in documents. If it is yes, go in, and then every single document you are going to check here. If it is yes, yep, the model is not hallucinating and answer seems relevant. If that is the case, you are going to set the state as useful. So if the model is not hallucinating but the answer is not relevant, then it's like not useful. So you can read these things that I just wrote, which it is in a simple English so that you guys can understand. And in model is hallucinating, retry. You ask the model to retry, and it can be seen here. If it is hallucinating, just retry. Generate a new answer for the user's query. Keep on going until you get a better answer. Yeah. And then now to the LangGraph, we are adding all these 4 attribute variables and their states. So basically now based on the state, it's gonna act. Yeah, now it's time to build the graph. We had all the individual components laid out in the form of functions or methods. Now we will go and piece it all together. So if this thing looks exactly like this graph, basically you start with routing, vector store or web search, retrieval, grade it after retrieving, and then all these things will be here. You start with route question, it's web search or vector store, and then from retrieval you grade the thing. Once you went inside grading, you are adding a conditional edge. It should be a web search or generate based on the relevancy of the retrieved documents, and then add another edge for web search alone. And then inside the conditional, the generate thing, we are trying to check for hallucination, right? So for a hallucination, we are having 3 things. is not supported, useful, or not useful at all completely, then go to web search. So if it is useful, that's all, the graph ends. If it is not supported, generate again a fresh answer, right? If not supported, generate a fresh answer. If it is useful, just end the graph basically. And if the answer is not at all useful completely, then go for a web search. So that's exactly what it is here. And the final results, when you run this workflow graph, compile that and start running it, and then here you can ask what are the list of drugs. In my case, I have asked that question, and you can see the question, and then it takes the data source as vector store. So my question is relevant to the retrieved content, so it is taking the answers from the vector store, and it goes to RAG, and now it's checking every document that it has took and checks its relevancy, and finally it has decided to generate, and the generated model has to be checked for hallucination, right? So check for hallucination. Here you can see model is not hallucinating and the answer seems relevant, so it's useful. So it's basically giving you the final end part with the answer whatever I asked for. So it is giving me the name of the drugs. And yeah, one more example, how to treat opioid addiction. So basically in my document it doesn't say anything, any explanations. So here if I ask that, it basically decided it's a web search. That's an awesome thing, that the model is comparing the user's question with the retrieved documents, and it understands that it does not make any sense, so it goes to web search. And yeah, checking for hallucinations and all those things, model is not hallucinating and answer seems relevant from the web and according to the provided context. Yeah, in this case the medications for opioid addictions include methadone and buprenorphine. These two are opioids, by the way, it's all addictive. But I'm not sure about naltrexone. Naltrexone is like an antagonist, that means people who are having opioid addictions are recommended this drug to get over the addiction to opioid basically. So yeah, that was a small error, but it's fine. It is just taking the information from the web, and it is essential to talk with the doctor to find out what treatment works better and for your loved ones. Awesome. Yeah, so that's it guys. I mean, if you want, I can run this code just to show you. I'm not sure whether I ran all these things though. Okay, let me run it real quick. Yeah, build graph. This is done. It's done. Let me run this one section of code, and let's see what are the list of drugs. So you can also see in real time like how much time it takes for my PC to do the answers. I have a 3070 RTX GPU, so it is good enough to answer. It has 8 GB of VRAM. Yeah, it is going to the vector store, it's checking the document relevancies. Awesome. Decision generate, finish, and it's gonna generate the answer, and then you'll check for hallucinations. Yeah, model is not hallucinating and answer seems relevant, and the final answer is this. Awesome stuff. Yeah, injectable anesthetics, nice. Antagonist, see, antagonist of opioid receptors, naltrexone. Okay, and everything works. So that's it guys, thank you so much. Some other important things that I need to talk is the how the prompt is taken in by Llama 3. This is very important. Do check this out, how they are explaining that you have to give your prompt in such a way that the Llama 3 understands. So yeah, and thanks once again for the LangChain team for their reference code. And this is my YouTube channel. If you guys are interested, please feel free to subscribe. I'll do more artificial intelligence content, and I also do a lot of animal related stuff, so, and some personal stuff. Thank you so much, guys. I hope you enjoyed this video, and if you have any queries or if something is not working, please put them down in the comments. I'll try to help you out, and have a nice day. Cheers.